Awesome. Hello, everyone. This is Natasha from Nextwork here, and I'm very excited to be going live with another amazing AWS project with you all today. Now, I hope you can see my screen. It's showing up a little bit blank for me right now, but let me know in the comments if you can't see it. Otherwise, I'll be jumping straight into it. All right, so today's project is the final part of our AWS and Kubernetes series. Well done. It is a really, really nice project that just ties together all of our learnings throughout this entire series. And yep, we are deploying Backend with Kubernetes today. So this is part 4. And if you haven't done the first 3 parts of the project yet, that's totally okay. We will actually be repeating a lot of the steps in the projects from projects 1, 2, and 3, all 3 of them, and you'll be totally sweet. I'll be explaining each of these steps like usual, but just know that if there's a part that you don't quite understand or you think, oh, like Natasha's going a bit fast in this step today, that's because we've already gone through those steps in parts 1, 2, or 3 before, and you're totally welcome to check out the live project demo for that or check out the project guide for that to have a more detailed explanation. All right, so in this final part of the Kubernetes series, now we'll be going through those first 3 parts like I mentioned before, where we would have learned how to deploy an EKS cluster. Chef's kiss, this one is truly the foundations of Kubernetes and being able to deploy applications with Kubernetes. Then we'll be building a container image, which is what we did in the second part of the series. After that, we will be setting up some manifest files. And manifest files are the instructions that tell Kubernetes how you want it to deploy and run your container image on the EKS cluster, which effectively deploys your application. So if we want to check out the architecture diagram, the architecture diagram for today's project, this looks really cool, doesn't it? So you can see that we have some parts that are already ticked off from the first 2 projects of the series, and we'll be repeating those steps today as well. And then part 3, in today's project, we'll be just tying all the loose ends together and making sure we get to that beautiful deployed backend at the very end as well. Okay, so what's the game plan here? Well, since we'll be starting from the top, we'll be going from the very, very beginnings of a Kubernetes cluster by launching an EC2 instance. So that's actually the very first thing that we're going to do. And this EC2 instance, you can think of it as kind of like your center place for managing everything for this project. You know, whether you want to pull some code later on, you want to install a dependency later on, you want to maybe write some files later on, you can think of this EC2 instance as the home of all the actions you're about to take for this project today. And once you've launched that instance, we'll be installing a key tool called EKS and this is the tool that's going to help us create an EKS cluster just from the command line of your terminal, just from the command line of your EC2 instance. So EKS you can think of it as that tool that we're using to create an EKS cluster, but it isn't the EKS cluster itself. Okay, so the EKS cluster that we're about to create is in this other service called Elastic Kubernetes Service, or EKS. So what is an EKS cluster and how is it related to Kubernetes? Well, in this scenario here, an EKS cluster you can think of as kind of like the brains of Kubernetes here. So Kubernetes is a tool for managing multiple containers that are all running similar or the same application together. So you can think of it as kind of like a manager for multiple containers. Now, EKS is a service that helps you with using Kubernetes and making Kubernetes a lot easier and a lot more connected to your AWS infrastructure. So when you have your EKS cluster set up, you can think of this as the control space for all of the containers that you're wanting to orchestrate or coordinate together to deploy your application. So what that means is EKS doesn't represent like all of the containers that you'll be creating. You can think of EKS more as like the the place that's like herding all of the containers together. So there will still be containers that are created separately, and those containers will be run by nodes. And all of this you'll get to see in action as well throughout the entire project. So if it's getting a little complicated, just know that we'll be going through it step by step. Okay, so we've got in step 1 an EC2 instance. We've installed EKS-CTL, which helps us launch an EKS cluster that you'll find over here in this service, EKS. So that's part 1 tick. Now part 2 is figuring out what application you actually want to deploy today and making sure it's ready for Kubernetes deployment. How we're going to do that is by pulling some code that our team member has made today. Your team member says, hey, I've got this application ready for you, and here is the backend code that I've prepared for that application. And you'll say, sweet, where's that backend code? And they'll say, oh, it's in my GitHub repository. Well, all you have to do then is to visit their GitHub repository and then pull their code, or really clone the repository, so you have a local copy of your team member's work. That local copy, you might have guessed, is going to be living inside your main project space, which is your EC2 instance. That's going to basically just host all the files, like hold all the files that you'll be creating and pulling and editing today. So you pull from GitHub, get your team member's code, and then you're going to do some magic to make sure it's ready for Kubernetes deployment. So why can't we just get the code and then tell EKS, hey, like I've got the code now, can you just go and deploy it, create some containers for me, off you go? Well, the reason for that is because Kubernetes can't just take some raw code that you've pulled and then deploy it straight away. Don't forget, Kubernetes is about managing containers for you. And in order for you to work with Kubernetes, you need to make sure that your application is actually in a container image. So what that means is you need to go through 2 extra steps to make sure that you build that container image that Kubernetes can actually use and run. And then you push that container image into a registry, or ECR, which is our registry of choice today, so that Kubernetes has a place to find it and take it. Okay, so that's part 2 done. So in part 2, really, what you're doing is you're taking some code, you're building a container image of that backend application that you've pulled here, and then you push that container image into somewhere that Kubernetes or EKS, your EKS cluster, can pull from, can take from. So when you've set up your application, then the final part is to do the deployment. You've set up your EKS cluster. You figured out a way for your application to be accessible by EKS and in a way where it can actually deploy the application. And now in part 3, you're really just doing the steps to tell Kubernetes how to do it, how you want it to deploy it, and then making it happen over here so that there's a deployed backend at the other side of this. So what this is going to look like is you'll actually be creating something called manifest files that are the instruction sheets that tells Kubernetes how you want to deploy today's backend application. You're going to say, hey, I want maybe 3 copies of this application. Maybe you want to say, hey, can you please make sure that the port that we're exposing is this port instead of that one? There are lots of different things that you'll get to explore that we'll see later on in this project too. So when you've set up your instructions, that's when today's project kicks in, and you'll be installing a special tool called kubectl that is the command line tool for helping us create the resources we need to create to make the deployment happen. So kubectl is going to be the tool that actually gets your manifest files and then gives it to your EKS cluster to say, hey, like here are the files, go and follow the instructions and make the deployment happen. And EKS says, all right, instructions received, and eventually deploys the backend over here. Okay, so huge project. I think we're going to do an amazing job. I love that we get to start from the top all over again, so you really get to see how all of these pieces fit together. And yeah, big shout out to everyone that's watching this live right now that's in the chat. If you have any questions at all, add them. If you're hearing this right now, please share. Please say hi in the chat as well. Say whether you've done Kubernetes before and whether there are any questions you might have. Who means? So with that overview of today's project done, we're just going to jump straight into it, yeah? So this project, we're just going to set up that backend of an app for deployment, parts 1 and 2. We're going to install kubectl right over here, and then we're going to deploy the backend on a Kubernetes cluster. There's also going to be a secret mission today where you'll get to track the deployment itself using the EKS console. And this is such a great step to follow so that you can really verify what you've done. Okay. Hey, hi Sai in the chat for saying hi. Thank you so much. Now, as you might notice, this is a pro project. And what is a pro project? So you'll notice that as a Nextwork Pro member, you do get access to an exclusive selection of advanced Nextwork projects, and these are called pro projects. Compared to the free projects in our collection, pro projects are where you're tackling harder challenges like this one. Look at how intricate and how much more detailed this diagram is compared to some of the other projects that we have. And then you'll be building some more complex solutions. I genuinely agree that these concepts are a little bit harder to learn because the concepts and the solutions themselves are a little bit more complicated and integrated than some of the other things we've done. Of course, these skills are also super in demand. Kubernetes, Terraform, multi-cloud architecture, so many things are coming out under this pro collection of projects that's going to come through to you. And I'm just super excited. And a big hello to Nick as well in the chat. Now, of course, you'll build up to solving some real-world problems that companies are facing. So get ready to get briefs from real-world companies around some things that their DevOps engineers are doing, some things that their network or security engineers are doing, and then tackle those problems at home. See whether this is something that you feel like you can challenge yourself to without a lot of guidance. Okay, now you'll notice that across these pro projects, there is a bit of an assumption almost that you've already done some projects before. So come with at least 4 or 5 Nextwork projects under your belt already, and out of those projects, just make sure you're familiar with EC2, VPC, CLI, S3. Okay, well, we'll dive into it, guys. We'll be following the high-touch version of this project guide today, which gives you the step-by-step guidance. Okay, and with that intro piece done, I'm going to switch my screen over so you can see my AWS console, and then the instructions will now live on the right-hand side of the screen. Cool. Alrighty. Cool. So now that we're getting started, what are we here to do today? Do we remember what this project is about? I know that was a big intro, so let's give it a go. In this project, we will... Hey Boris, nice to meet you. Oh my gosh, both Sai and Boris, I think have... Is that Luffy from One Piece in their profile picture? That's amazing. Hi Boris. In this project, we will deploy the backend of an application with Kubernetes. This project will start from scratch, i.e. deploying, launching an EC2 instance, and go all the way to having a live backend deployed. Don't forget to delete your resources as well. As you might notice at the top of this page, there is a spicy little price associated with using EKS in your AWS console. So let us mention that. Amazon EKS is not AWS free tier eligible. One day, everyone, one day. AWS charges 10 cents for every hour my EKS cluster is running. That's 10 cents an hour. So to minimize costs, we will, what are we gonna do, team? Do we know what we're gonna do to minimize costs? We will make sure to delete our EKS cluster at the end of this project. Okay? Simple as that. And we'll even give you the instructions on how to delete those resources too. All right. Wow. So cool to have Theophilus, is it Theophilus Hakim, saying hi in the chat too. Hello, hello. Okay, well, let us set up the EKS cluster now. To do this, we'll be launching that EC2 instance that we mentioned before, that home base for today's project. And then we're going to connect to that instance. We're going to go inside that instance. And then we'll run the commands to create the EKS cluster from there. Okay. And if you want a little refresher on what is EKS, EKS is Elastic Kubernetes Service. And this service helps you use Kubernetes to manage the containers you create on AWS. Setting up containers from scratch, setting up Kubernetes from scratch can be quite a time-consuming and complex task. Kubernetes is not an easy, very, very simple, straightforward tool to use. So EKS helps simplify it for us. Okay, it helps us with tackling admin tasks like networking, scaling, the security settings of Kubernetes, so that we can just focus on more of the application itself, creating the application. And that's why in this step, we'll be going through the first project in our Kubernetes series, and you can check that out to learn more about the concepts we cover here. So this step, we're just going to launch that EC2 instance, and then we're going to install a tool called EKSCTL. And then using EKSCTL, we're going to create that EKS cluster. If you're wondering why CloudFormation is in here, it's because EKSCTL actually uses CloudFormation under the hood to create all of those resources that we're going to see on the other side. We're not going to visit CloudFormation itself in today's project, but you would if you were doing the first project in the series. Mandar in the chat says hi as well. Hi Mandar, how are you doing today? Thank you so much for being here. I'm really excited to be showing you this Kubernetes project. Okay, so what are we doing in this step? In this first step, we will be creating an EKS cluster because it is the foundations for deploying with Kubernetes. A dependency we think we'll need to install is, can you tell from this list what kind of dependency we might need to install? Let me know what you think. Can we see anything that we might need to install to use? Now, I hope you've mentioned EKSCTL here. As you might have noticed, it's not an AWS service. It is a tool that we'll need to install to use. Okay, so a dependency we think we'll need to install is EKSCTL. Great. So once you've logged into your AWS Management Console, please, as your IAM user as well, for security reasons, make sure that you're not using the root user, but the IAM user. And if you're not sure what I'm talking about, please check out the link in the description box of this video that will show you how you can set up your IAM admin user. And with that all done, I'm going to switch to the right region for me today, which is North Virginia. Okay, and then I'm going to visit the EC2 console. How good, everyone. The EC2 console is going to be where we launch the EC2 instance for today's project. You can even see I have secretly made some nodes in preparation for today's project. But if you don't have any of these, just know you don't actually need it to start this project. It was just when I was testing it right before we started. So technically these shouldn't be here, but we'll just be launching that new instance today. So name your EC2 instance Nextwork EKS instance like this. Okay, and then for the AMI, choose that free tier eligible one that's called Amazon Linux 2023. And in our instance type again, choose the free tier eligible one. Now for key pair, we'll be selecting nothing. We actually want to proceed without a key pair today. And you might have noticed that usually we would use a key pair to connect directly to our EC2 instance, which actually we'll be doing later on in this project. But we won't be needing a key pair today because we'll be using EC2 Instance Connect to connect to our instance. And that tool basically bypasses the need for a key pair, so we don't need it today. But if you wanted to connect to your EC2 instance outside of using that tool that we're about to use, then yes, you'll likely need a key pair. All right, but we'll be just keeping that default network settings here, and then we'll just launch the instance right away. All right, I know that was a bit of a speedy launch of an instance there, so if you have any questions, you can ask in the chat, or you can also check out the demo for the first project as well, which is in the description box. Okay, now that we've launched the instance, it is simply time to connect it. So we'll just click connect here, and then we'll connect right away like this. So how we're connecting right now is with EC2 Instance Connect, as you might have noticed. Oops. Oh, I think I should be clicking connect here again. So as you can see, there are multiple ways you can connect to your EC2 instance, and we're selecting EC2 Instance Connect, which is the tool that lets us get access to our EC2 instance just over the browser. Look at that, I'm inside the terminal of my EC2 instance already. Usually you probably need to download that key pair, set it up in an IDE in your local terminal, all of that. But EC2 Instance Connect basically just saves us a lot of steps and gets us access to our EC2 instance right away. So now that we're armed with the power to access our EC2 instance, we're going to dive straight into installing the tools we need to launch that EKS cluster. So EKS CTL is the tool we need. So we'll be installing that right away. Okay, and there we go. It worked very, very quickly. And to verify that we've actually installed it, we'll just run EKS CTL version. Cool. All right, so when a version number pops up, I hope you can see this. So when a version number pops up, what this tells us that there's definitely EKS CTL that's been installed now, and we even have a version number. If you don't have EKS CTL successfully installed, what that means is your version would not pop up. They'll be like, oh, there's no version for this because you don't actually have it installed. If you see that error, just make sure to run the command for installing EKS CTL again. Okay, and we'll create the IAM role for our EC2 instance. Okay, so our EC2 instance has been created now. You can see we can even install a tool with it, so that's very helpful. But by default, our EC2 instance doesn't actually have access to our AWS account or have the power to use any of the AWS services that's in our account. That's the reason why we need to grant it an IAM role. So in this mini step here, we'll be granting it the permission to access and interact with the services in our account. Okay, so how we're gonna do that is by accessing, ooh, wrong button click, everyone. Actually, okay, if I were to just stay in that tab, all right, I could actually just access the console I need by clicking on the search bar and then typing in IAM over here. Open IAM in a new tab so that you can access it without having to close your connection to your EC2 instance. Okay, and when you're in IAM, we'll be creating a role. So let's create the role now. Click on roles in the side tab. You can create the role like this. All right, and then under use case, it's for an EC2 instance. So we'll give it to an EC2 instance and then give it the permission of administrator access so that when you enter the role name, whoops, When you enter the role name, we'll just be using Nextwork EKS instance role like this. Whoa. There you go, like this. Now, my role already exists, which means that I can't create the exact same role one more time. That's okay, I just really wanted to show how we can do this together. And you can enter a short description. So you can just enter the description over here like this, so that you can remind yourself that you've created this role. You've created this role so that your EC2 instance can have access to your EC2 instance can have access to your AWS account and all the services inside. Cool. And then you click on create role just like that, and the role should create for you. Now again, because my role already exists, so you might see that it doesn't create, but once you've created it, it'll be all good. It'll be in your account. Saya in the chat is saying, why not command line? Ooh, what do you mean there? Why not command line for a specific step? I might have missed your timing over there, Sai. So let me know. Okay, so once you have actually created the permission, the EKS instance role, does your EC2 instance have access right away? What do you think? So no, your EC2 instance won't have access right away because you've created the permission, but you haven't actually attached that permission to your EC2 instance yet. So you can think of the permission you've created and your EC2 instance is kind of like just floating around each other, but they're not connected yet. So we need to do one last final thing to tie them together. And that final thing is to visit your EC2 console, visit your instances tab one more time. And now, once you've selected your instance, make sure that you are under actions using security to modify the IAM role, and then giving it the EKS instance role that you've created earlier. Okay, so once that's done, it means that you have given your EC2 instance the permission to interact with your AWS services. Okay, now it has permission to do things in your AWS account. Great, that's what we wanted to do. When that's done, you can head back to your Instance Connect, which is connected to your terminal, and then run this little command over here that creates the EKS cluster. Okay, and then we'll be replacing your region over here with the region that you want your EKS cluster to be in. Ideally, that is the exact same region as the one you're using right now, so you can double check what the code is. For me, that's US East 1. For you, it might be something else. And then type that in here. Okay, off we go, and we'll run it. Looking really good. You'll see a bunch of output in the terminal straight away, and it's just the terminal telling you like, here's what's happening right now with the action that you're trying to do, which is creating that cluster. All right, so quick recap. What have we done? We've installed EKSCTL, and we've also set up an IAM role so that our EC2 instance has the permission to do things in our AWS account, like creating an EKS cluster. So now that we've installed EKSCTL and our EC2 instance has the power to do things in our account, we ran this command that says, okay, now use EKSCTL to create the EKS cluster, and here's what we're going to create. Here are the settings for the EKS cluster we want to create. The name should be this. It should have a node group, and a node group you can think of as kind of like a big group of a big wide group of containers that can be split into multiple little parts called nodes, and we'll go into that a little bit more detail as well. And each node should be using t2.micro as the instance type, so on and so forth. So there are a few details that we tell EKSCTL on how we want to create that EKS cluster. And Sai asks, can we do the same in the terminal using SSH? Absolutely you can. You definitely can do that. You'll just need to make sure that you are using a key pair to do that. Cool. The reason that we're using EC2 Instance Connect is because it is most compatible with everyone's devices, whereas when we're using the terminal, oftentimes some students who are less familiar with using the terminal might run into issues, especially if they're using a device that isn't quite compatible with some of the instructions that we're using today in terms of connecting to the EC2 instance. So EC2 Instance Connect is probably like the safer way that's going to guarantee you can have access to your EC2 instance. But you can definitely use the terminal as well if that's your preference. Okay, so how did you set up your Kubernetes cluster? Let us answer that question. To set up today's project, I launched a Kubernetes cluster. Oof. The cluster's role in this deployment, what is it? Can we think of what the cluster's role is in this deployment? Yeah, it's a bit of a tricky question as well, so you can always refer to some of the tips we have over here to answer that question. You can also use Simplify to get even more explanations on what you've highlighted if you'd like to know more. Okay, so in this case, we're going to say the cluster's role in this deployment is to be the control center for using Kubernetes and orchestrating all the containers that will be running the application we want to deploy. Nice. And if you wanted to just have a better read of this, the EKS cluster is the control center. It is like the brains of the operations today. Kubernetes is scheduling containers, managing resources, handling tasks like scaling, networking, and updates for you. So how do you communicate with Kubernetes what you want it to do? Like, how do you want it to network? How do you want it to scale or manage updates? You tell Kubernetes kind of all of these preferences over the EKS cluster. And to access your EKS cluster, you can use the Amazon EKS console. You can also use the command line. And there's also some cool things like manifest files that we'll be talking about that gives Kubernetes instructions on deployment as well. So long story short, think of EKS and the EKS cluster as the brains of the deployment process. And when you deploy something, just know that the EKS cluster is where Kubernetes figures out how to take your app, runs them on the group of containers called nodes, and just make sure everything is staying up and running. All right, so with that first step out of the way, we can now pull the code for the backend. So you don't need to wait for this to finish creating. An EKS cluster takes 20 minutes sometimes to actually create, but we don't need to wait. We can move on, and we can move on to the next step. That's about part 2 of this entire deployment process. Okay, so we'll be using GitHub to get our team members' code and pull it into our EC2 instance in this step today. Now, the code that your team member has prepared is actually the backend of an application. It's not the entire application, it's not the backend and the front end and other services that it's using, it's just the backend. And this really keeps things simple for us so that we have one thing we can focus on deploying. The backend is like the brains of an application. Wow, we're using the term brain quite a bit. But if you can think of the EKS cluster as the brains of this entire Kubernetes operation, the backend is more about what's actually happening in your application itself. And the backend is the brains of how your application works. You know, how does your application know to display a certain page when you click on a certain link? How does your application know to process some of the things that you're putting into the application to give you some customized content out? How does your backend know to for example, how does your application know to process some data that you put in so that it can process a transaction for you? For example, if you want to buy something over Amazon. So unlike front-end code, which is what you really see and interact with and you click on, back-end code is kind of like the brains and the logics that runs on the server side in the background. All right, so the two parts of this step is we're going to first make a copy of the backend code by pulling from our team members' work. And then we're going to build a container image using the backend code as well. So that's actually this little step here. That definitely should be highlighted, everyone. Although I think, actually, we might have split that step up. So building the container image is actually happening a little later. Cool. Let me know if you have any questions in the chat. And if you get stuck as well, check out the second project of this Kubernetes series for a detailed explanation of what we're about to go through. Cool. So in this step, we will pull our team members' work, which is some backend code in GitHub. We're doing this because we need to access the code we want to deploy. Pretty simple, straightforward explanation, but it's completely true. We simply need our own access, our own copy of the code that we want to deploy. A dependency we think we'll need to install is, can you tell what we might need to install? I didn't really mention it straight up, but there is a dependency, something you'll need to install. Can you tell what it is just from this diagram alone? And a big shout out to Almighty in the chat. Thank you for saying thank you for your hard work. That's really sweet. Okay, so a dependency we think we'll need to install is Git. Done. All right, so while our EC2 instance is just busy creating that EKS cluster for us, we can set up a new connection to the same EC2 instance simply by going back to the EC2 console, clicking connect one more time, and then connecting with that instance again. Done. We have set up another connection in parallel to this first one that's busy doing some work for us. And don't worry, even if you run some new commands over here, it's not going to stop your progress in the other tab. You can just think about your EC2 instance as doing some multitasking right now, running two separate lines of work for you. One is busy, one part of your EC2 instance is going to be busy creating that EKS cluster, and the other part is going to be busy running the commands we're going to send it now. Cool. So like we mentioned just now, a dependency you'll need to install is Git. So let's install that right away. There we go. Off we go with installing it. And Git is a version control system. So a version control system is something that will track changes in our code, but the reason why we're installing Git is because Git is also very helpful for sharing code and getting specific versions of other people's code. So what's really happening in the background is your team member that created the backend code used Git to say, oh, save this version of my code. Thank you very much, version control system. And once that version is saved, let me push it up to GitHub. So that version is up in GitHub now. And what we're gonna do is we're gonna say, oh, your version that's up in GitHub, the latest version, let me copy that and bring it down to my EC2 instance, and I'm gonna install Git so I can actually do the copying, okay? Great. Now, as always, check the version of what you've installed to make sure you've actually installed it. And we do have a version number. That means we've installed Git. And we're gonna configure it by just running these two commands below, and make sure you can replace the placeholders here, like the username and the email, to your own details. But Oh, oopsie daisies. But if you want to just run this template, I think you should be okay as well. We won't be using the details for that we're setting up today for anything else. This is more just like a very common setup step to do once you've installed Git. It's to set up your identity in Git. Okay. Now that we have Git all installed, we can actually just use cloning to get a full copy of our team members' backend code. Now, cloning is a super handy feature. It literally means that you're getting a full copy of an entire repository's code, and we can do that just with one command. All right, so in a new tab, we're going to need to visit our team members' GitHub repository. So right-click on this link, copy it, and you can open that link up over here. Great. So now that we're in this repository, this is where your team member has hosted all of the code that you need to run your backend application. There's even a Docker file, there's a README, there's the actual app code itself, there's a bunch of requirements that you'll need to successfully run the application. And we just need to click on code here and copy this HTTPS URL. Okay, so this HTTPS URL is kind of like the directions or the address of your repository. Now we need this because we need to tell our EC2 instance where to find the code it's about to clone. Otherwise, there are just millions and millions and millions of repositories out there. How is your EC2 instance going to know which one it's gonna clone? So with that URL copied, we'll run git clone over here and just paste that link here so that we can clone it straight away. Oh, a big shout out to Hakeem for asking, can we use any other version control but Git? Good question. I think you should be able to. What other version control systems are you thinking of using? Git is truly the most common one that is most familiar. That is the most familiar one that we'll be using for our projects. But yeah, add it to the chat if there's another control system that you're wanting to use, and we can look into it too. Great question. So once we've cloned it, let's check it out. So you can run ls in your terminal here. And once you run ls, you get to see you get to see a folder that's called Nextweek Flask Backend. Does that name sound familiar? Well, it's simply the name of the repository that we've cloned. So what's going to be inside this little folder that's in here now? Can you guess? If you're not sure, you can even run ls nextwork. Whoa. You can run ls nextwork flask backend like this to even see what's inside the folder. Haha, 4 files. All 4 of them, exactly the same as what your team member has put in their repository. So can you see how cloning is just fully making that full copy of everything that your team members put in here? Very nice. So when that's done, we can move on to the next step. But I also wanted to quickly call out that there's a little question here about why does the repository name say Flask? Okay, so this is a great question. If you're wondering that, the reason for that is because your team members' backend code was built using a framework called Flask. And a framework is just this set of tools or guidelines to help developers build their software. Flask is one with Python, and Flask comes with a lot of pre-built components that helps make building web applications very, very easy. So your team member just went and used Flask to build their backend, and they've just referenced that in the repository name as well. Okay, if you want to know more about Flask, you know what to do. You can use a bit of simplify, and you can even simplify the work as well to just keep digging deep into a concept you might want to know more about. Okay. Oh, Bamisha's in the chat today. Bamisha, hello, good to see you here. And Bamisha's asked, is the git clone the same as using git remote add origin. Oh, good question. Not exactly the same. Not exactly the same. So Bamisha, git clone is when you make a full copy of someone else's code, someone else's repository. Git remote add origin, you're starting to make a connection between your local workspace and your team members' repository up in the cloud. When you use git remote add origin, you're basically saying like, I'm going to set up a git project, and when I make changes to the code here, I also really want to track those changes and potentially push those changes to my team members' repository in the cloud. So you can see that there's a connection getting set up now. When you make changes that you want to push, you can do that because you ran git remote add origin. But in our case, we don't actually want to make any changes to our team members' code. We don't want to affect whatever's inside the repository that your team members set up. We just need to copy it. And that's why we're using git clone instead. Yeah. All right. And very cool. Boris in the chat also asked, I made a similar project in Google Cloud with a microservice backend. It's necessary a cluster for monolith backend, one Docker container. Oh, great question. So a big assumption that people might have about Kubernetes in general is that you just need to see it, you just need to use it all the time when you want to use containers and you want to deploy something with containers. But that's not always the case, especially when you're using a monolith, okay, and it just requires one Docker container. You would use Kubernetes when you want to manage multiple containers, when you need to literally orchestrate containers. Think of Kubernetes as the tool for kind of like herding containers together when you have a lot of containers to take care of. It's not exactly what you need if you only have one single container, and one monolith backend. If you have your backend split up into lots of different pieces, and you want different containers to be running those different pieces, or you need different containers to run together, to set up all the pieces together, that's when you'll be using Kubernetes. So as you might imagine, Kubernetes is very, very helpful when your backend application or whatever you want to deploy is quite a large one that's already been split up into chunks that you need to launch separately. And that's the reason why Kubernetes is so popular for larger companies with larger applications in separate parts that they need to manage separately as well. So yeah, I hope that gives you a bit more context, Boris. Okay, cool beans. Now I got a bit trigger happy over here by going ls next with Flask backend, but as you might notice, the instructions here actually say cd next with Flask backend. What's the difference? Does anyone in the chat know? By going cd next with Flask backend, you're navigating your terminal inside the folder, and then you're gonna say what's inside the folder that I'm in right now. Okay, it's slightly different way of doing things, but it achieves the same results. Okay, so there's no wrong answer there. Okay, so we have confirmed that we have pulled our team members' work now, and let us answer this little question to tie it all together. I retrieved backend code by pulling my team. Oh, actually, we retrieved backend code by cloning our team members' repository. Hey, shout out to Bamisha for shouting out what cd means. That's completely right. You're changing the directory into the folder when you run cd. So we retrieved backend code by cloning our team members' repository in GitHub. So we have a local copy of their code, of their work. Okay? Pulling code is essential to this deployment because, do we know why? Why do we actually need to pull code for this deployment? Well, if you noticed, it's a bit of a tricksy question because it needs you to have an idea of the big picture here. If you noticed in the very first introduction for today's project, we mentioned that you need to actually build a container image of whatever you want to deploy so that Kubernetes can actually use it and run that application. If it's not in a container image, Kubernetes ain't deploying it. Okay, think of it in that way. So the real reason why we're pulling this code from our team members' repository is because we need to access it to build a container image of it so that Kubernetes will deploy. I'm running out of characters. We can say we retrieve backend code by cloning our team members' repository in GitHub, by cloning a repository in GitHub, so we have a local copy of our team members' work. Pulling code is essential to this deployment because we need to access it to build a container image of it so that Kubernetes will deploy. Pulling code is essential because we need to access it to build a container image of our application so that Kubernetes will deploy it. I'm a lot happier now with this answer. And yeah, thank you, Boris. Cool. Step 3, we're going to build a container image for our backend now. And this step is actually so crucial. The more I think about it, the more I'm like, wow, if this step didn't exist, or really if any of these steps that we're about to do didn't exist, like this Kubernetes deployment would not go, like it would not happen. And that's the reason why this project is just so beautiful. Like you get to really see every single step that makes a Kubernetes deployment happen. So when you deploy a containerized app to Kubernetes, Kubernetes needs to pull that app from a container image it can access. Okay, so if you think about it in a little comic, let's say you say, let's say Kubernetes is like, here, hey, I'm Kubernetes. I can deploy a containerized application. And the backend code just goes to Kubernetes and say, hey, I'm code. Come and deploy me. I'm ready for the world to see me. And then Kubernetes is going to say, yo, no, where's your container image? I'm here to deploy containerized applications. And containerized applications have a container image. Okay, they're packaged inside a container image. So your raw code is going to be really embarrassed here. And it's going to say, oh, give me a second. Because in this step, we're going to build that container image that Kubernetes can accept and actually use to deploy. Very good. Now, if you're new to the concept of container images, just know that container image is absolutely essential for Kubernetes to deploy an application consistently. That's the reason why Kubernetes really needs it. Because when Kubernetes is managing a whole bunch of containers together, what happens is Kubernetes needs to have the power to shut down containers that could be faulty or aren't working or we don't need. And it also needs the power to create new containers on demand. So let's say when traffic is really heavy now, you need more compute power to run your application. Kubernetes needs to be able to just on demand create new containers for you. Now, it can't create those containers on demand or just manage your containers very, very well if it doesn't have that container image, because the container image is what Kubernetes will need to figure out how to even create that container. And that's the reason why we really need it for this deployment. Okay. Very cool. Start your answer with, in this step, what are we doing today? In this step, we will build a container image of our backend application. Or we can say of our application's backend. Because Kubernetes needs the application to be packaged up or containerized in order to accept and deploy it. A dependency we think we'll need is This question is so good. What is a dependency you think you might need for this? Can you tell? Every time you see a little icon that's not an AWS service, chances are there's going to be a dependency you'll need to install, all right? And in this case, what's this little guy over here? This little guy is Docker. So Docker is going to be that tool we use to even build the container image, and we need to install it. It's a dependency. Okay, so a dependency we think we'll need to install is Docker. All done. Okay, so now that we know we need to install Docker, let's do it right away. Let us run this command to install Docker. Off it goes. And in general, just know that Docker is a tool you'd use to create containers. And then when those containers are created, or when you've created a container image, then Kubernetes will be coordinating them, herding them together. Okay, so once that's created, we'll start Docker over here, started it up, boot it up, and then we'll make sure that we have access to what we've just created here. So we'll give ourselves access by running something called whoami, and it's a command that basically asks your EC2 instance, what user am I using to log into this EC2 instance right now? Because don't forget, an EC2 instance is literally a computer in the cloud. And just like how when you turn on your computer, you have to type in a password maybe to get access, when you're using a EC2 instance, you can log into that instance or access it using different kinds of users. So in this case, we're using the EC2 user, which by default doesn't actually have access to Docker commands, like can't actually run Docker commands. So we'll need to make sure we can run or use the tool we've just installed. Cool. And to do that, we'll just have to add the EC2 user to a Docker group. So we'll be using this command here to basically say, hey, there's a group, or there's a way to organize permissions inside an EC2 instance called groups. I want to join the group that gives me access to Docker commands, lets me run Docker commands. Okay, so we ran that command now. And we'll need to make sure that those new instructions, or the fact that you've joined this Docker group, loads because group changes usually don't take into effect until you start a new terminal session, and we're still in the same terminal session that we're using right now. So if I were to just use the command, actually let's just do this now. If I were to use the command that lists out all the groups that my EC2 user is in, great, you can see Docker is in here, which means that we have access to Docker commands now, and we just need to refresh our tab usually to let that take into effect. Refresh. Okay. All right, so okay, we're in this new terminal session now, and that means we can now start running Docker commands too. Again, if this step feels a little fast, just know that more detailed explanations are in the step-by-step guide, and it's also in project 2 of this series, where we really go into the details of why we need to use, why we needed to run those commands. Okay, let us again run a cheeky ls if we want, to double check that we still have the repository or the backend code that we've copied. And then we will navigate into it. And as Bamisha in the chat kindly pointed out, that's what you do when you run cd in your terminal. Great. And now that we're here, you can run that cheeky ls one more time to just make sure you still have all the files in the repository that you have cloned. Okay, so with that all done, and now that we definitely have access to run Docker commands, let's run the command for building a Docker container image. Off we go. Yeah, and building a container image is a bit of a process. So let me quickly use this time to talk through what's going on here. When your team member prepared the app's backend, they wrote a file called Dockerfile. Do you see that file over here? It's called Dockerfile. Oh, there we go. So they wrote a file called Dockerfile. And this Dockerfile is a instruction sheet that tells Docker how to build a container image of the app that your team members created. So when you ran this command that says docker build next class backend dot, you're basically saying, hey Docker, in this current folder, you'll be able to find a Docker file. Open that file, look at the instructions inside that file, build a container image using those instructions. And once you've built the container image, we want to name it next class backend. Done. So that's what you've done by running this command. And if you want to know more about what's inside a Docker file, you absolutely can. If you'd like, you can even just click here, click into the Docker file in the repository, and you can see what's inside. Very nice. Okay, so we've finished building that Docker image now in the time that I was yapping away about what this command means. So once we've built it, what's going to happen in the background is, Docker has created that container image of your code, okay? And you can say like this backend code is now inside an image, right? And this image is also going to package up all of the dependencies, all of the things a container will need to have in order to run the application well. And with that Docker container image built, what's going to happen next is later on you can go back to Kubernetes and say, hey, container image is here now. You can absolutely deploy me using this container image. And that's how Kubernetes is going to create new containers. It's going to create the containers in your EKS cluster using the image that you've provided. Okay, very good. Nice. So let us answer that final question before we move on to the next step. Why did you build a container image? Once I cloned the backend code, I built a container image. Once we cloned the backend code, we built a container image because Kubernetes needs our application to be packaged in an image to deploy it. Without an image, what would be difficult? I just noticed that there's a bit of a typo there, which is kind of embarrassing. So without an image, it will be difficult for Kubernetes to deploy our application consistently across the cluster, across a cluster. Great. So with the container image built now, tick, we have done quite impressive stuff, okay? We've already launched an EKS cluster. We've pulled our team members' code. We've built a container image of that code. Stunning work, everyone. Now in step 4, we're going to push the container image that we've built into ECR. So container registries, like Amazon ECR, they're like storage spaces for container images. They give container images somewhere to live so that later on they can be accessed by EKS, accessed by other services. So in this step, we're going to get ready to store the Docker image of the backend in a repository. Otherwise, it's only just going to live in your instance, which isn't the most safest place to be. Okay, it's kind of like how code needs a place to live in order for other people to pull it. You know, like our team members back in code needed to live in GitHub so that we can pull it. We couldn't just pull it directly from our team member's computer. And that's the same for our container image. We've built it, but EKS ideally wouldn't have to just pull it straight from your computer. It can pull it from a better place for storing these images, like ECR. Okay, I hope that was clear. In this step, we will push our container image into a repository that we create in Amazon ECR, which stands for Elastic Container Registry. And why is that? This will give our container image somewhere to live so that Kubernetes can pull it easily for deployment. And really by pulling, we mean accessing it. Alrighty, so once it's done, we'll click done, and we will jump straight into creating the repository. Now, don't forget, great news, our EC2 instance has administrator access, which means that you can really use it to access any kind of AWS service and create any kind of resource. That's the reason why we can even use the terminal here today to run the command to create a new ECR repository. So let's copy the code to do that, and let's run that now. Phew. Let us create the repository, and this is some great feedback from the terminal to say that it's been created. And here are the details. You know, here is the ARN for it, the ID of it. Here is what it's called. Here's even the URI. Great stuff. You can even see some details like that. So that's really, really helpful. Okay, and if you wanted to get a refresher on why that ECR repository exists, you refer to this little flow diagram here that goes from your coworker writing the code all the way, oh, I just realized I can't see that. Your coworker writing the code all the way to you copying their code, you know, you pushing the container image into a repository, and then now Kubernetes will pull the image from ECR to deploy the app. Okay, just a little reminder of this flow that we're going through. Oh yeah, and if you're new to container registries, we actually have a whole project about them. So you can check out our project on using Amazon ECR, which is also in our YouTube channel too. Very nice. Cool. So let us head to ECR straight away to figure out, to validate that we've created it. So we're going to use the search bar, type in ECR over here, and you can open the container registry in a new tab. So can we actually see our repository? Yes, we can. It's been created. It's over here, and it's looking really good. So once you've confirmed that it's been created, you can go through the instructions for now pushing the image you've created into here. So it's kind of like we've just set up a folder that's ready to store a container image, but it doesn't have a single container image in here right now. You can see the count is 0. So we're now going to be running something called push commands that basically we're going to run in our EC2 instance so that our image that we've built of the backend can go in here. It's kind of like the uploading process. That's what push commands do. It kind of just uploads the image we've built into the repository. Okay, so we'll open the push command window. We'll copy that first command. Okay, and we'll run it. It's a series of 4 commands. Oh, wrong tab. This tab. There we go. We'll run that first command. Succeeded. Great. We'll run that second command, which we don't need to do because we've already built the Docker image. Okay, what the second command is about is already done. And then we're gonna tag it Okay, and then we're gonna push it. Cool. Great. So all those commands help us with making sure that Docker is authenticated with ECR, so that the Docker image that you've created can be pushed into this container registry or your repository. And then that third command, command number 3 that we ran, is about tagging it. We're putting on this label that says, you are the latest image that I've built. So now, later on, when Kubernetes says, I just want to pull whichever image is the latest one in this in your ECR repository, it can easily just grab the latest one because you've tagged it latest. That last command, command number 4, is about pushing the container image. So that's about actually doing that upload into your ECR repository. So shall we check that it's there? I think we can. So we'll just visit the ECR console again. We'll click close. So we close the window. It's not here, but that's okay. We just need to refresh. And once we've refreshed the console, like magic, our latest image, see how it's tagged latest, is right over here. That looks really good. Nice job. All right, so I hope that was all clear with everyone. Did any of the instructions not make sense? Do we want to go through any of these steps again? Let us know in the chat. Or if everything's been going good, you're enjoying it, you can give us a thumbs up as well in the chat too. Okay. So before we move on to the next step, this step has been a success. We can see that the image is in here now. It looks really good. But before we move on, a good question to ask is, does the image actually need to be in a repository? Do I have to save my Docker container image in a repository for Kubernetes to deploy it? And the truth of the matter is no, actually. Kubernetes doesn't have to pull container images from a remote repository like ECR. The reason why we are using it is because it is absolutely best practice to do, so that you have a repository, you have a folder, you have a center point that manages your container image, always has the latest image in there. You even have tags to make sure that different versions can be tagged differently, so that Kubernetes can automatically pull different versions that you want it to pull. And it also is just a great place to automate any changes that you want to make across your entire Kubernetes deployment. Okay, so imagine this. You make a change to your app, and you're like, oh man, now that I've changed my app, the container image that packages my app needs to update too. So you build a new container image for your app. Great. Now that you've built the new container image, how are you going to tell Kubernetes to just pull this new container image across all of the containers that you have? The great power of Kubernetes is once you give it the location of the latest version of your image that's in a repository, Kubernetes will say, okay, I have the latest version. Let me just update every single container inside your EKS cluster, inside your deployment, with the latest version. And it's just so easy and simple. Because the image tag, because you can just replace whatever image is latest here, you don't even have to change the references in the files that you give Kubernetes or the instructions you give Kubernetes. Because the instructions you give Kubernetes can be standardized and just pull whatever's the latest one. But if you weren't using a repository or a registry to manage that for you, it is likely that you'd have to go through a lot more steps just to tell Kubernetes, like, hey, can we update our app to this latest image that I've created? So yeah, repositories for the win. So good for the long-term management of an app, and that's the reason why it's best practice as well. Okay, so with that done, let us answer this final question. I also pushed the container image to a container registry. which is a storage space for container images in the cloud. ECR, Elastic Container Registry. I had a mind blank there. I don't know if you caught that. And thank you so much for everyone in the chat for chucking some lovely emojis to let me know we're going well. Okay, so ECR facilitates scaling for my deployment because Kubernetes can easily grab whichever image is tagged latest and deploy that. Yeah, I think that's okay actually. I was having second thoughts about what I was writing there, but ECR facilitates scaling for my deployment because Kubernetes can easily grab whichever image is tagged latest and deploy that. I want to say deploy that. Use that for each container in the cluster. Can easily use whichever image is tagged latest for each container in the cluster. My goodness. I'm gonna just make the first part of my answer a bit shorter. I also pushed the image to a container registry, which is a storage space for container images in the cloud. ECR facilitates scaling for my deployment because Kubernetes can easily use whichever image is tagged latest for each container it creates. I think that works. As you can see, I'm a bit of an overthinker as well with the things I write, but I hope you guys are happy with this response as well. And if you have a different way of answering the question, I'd love to see it. If you add that to the chat, everyone. Okay. So now that we've pushed a container image to Amazon ECR, our container image has somewhere to live now in the cloud. And we're about to do one of the final steps for getting ready for deployment. And that is to create something called manifests. I have to say, manifest is probably one of the newer concepts that this project will introduce you. Maybe some of these other concepts you would have learned from previous compute projects or container related projects with Nextwork. And manifest is the one where we haven't really introduced it before, so it's a bit of a new one. So in this step, with the image now in ECR, we're ready to deploy it to our EKS cluster. We'll use Kubernetes manifests to tell Kubernetes how we want it to deploy the application. Yeah, so just like how a Docker file gives Docker instructions on building a container image, you can think of Kubernetes manifests as another instruction sheet. Okay, but who it's for? Kubernetes manifests are not for Docker, it's for Kubernetes. And it's not about building a container image. This instruction sheet is about how to deploy my application, how to run my application, because Kubernetes doesn't really know your preferences by default. Okay, and you've prepped all the ingredients. You have the application in a container image that's in a place that Kubernetes can access it, and now you just need to tell Kubernetes like how to get it and how you want Kubernetes to deploy it. And yeah, think of Kubernetes manifests as blueprints that define the desired state of your app, like which container image it would use, how it's going to be available to your end users, what kind of ports you might be using. And then, now that Kubernetes knows what the desired state is, it's going to actively try to deploy it and make that deployed application look exactly like the desired state you've mentioned in your manifest files. Great. So we're going to be creating two separate manifest files, so two separate instruction sheets in this step. One is called the deployment manifest, and one is called the service manifest. The deployment manifest is about how to deploy the containerized backend, and the service manifest is about how to expose the application and route traffic to the backend that we've deployed. Oh yeah, and if you get stuck in this step, we do go into every single part in detail in the third project of this Kubernetes series. Okay, but let's jump into it now. In this step, we will create Kubernetes manifest files that give Kubernetes the instructions. Oh, because they give Kubernetes the instructions on how to deploy and expose our application. Nice. Ranga says, what scripting language are you using? Ooh, depends. Which script are you referring to right now, Ranga? What are you seeing? Let us know. Great question. If you're talking about the manifest files, you'll see that they're written in YAML. Great. So let us create a directory for the Kubernetes manifest. And we're going to head back to the EC2 Instance Connect tab. And I'm going to quickly note down that to be very, very clear that we need to be running these commands in that EC2 Instance Connect tab. Cool. All right. So once we're here, we'll be running the commands to create this new directory from your instance's root. So how you're going to do this is you just run these 3 lines that basically says, okay, from the root of this EC2 instance, please create a new folder and call that folder manifest. We're also going to go into that folder itself. So we're inside the manifest folder we've created now. And we're about to run the commands for creating the files themselves. We've created the folder for it, but we haven't created the files yet. Okay, so let us respond here. Kubernetes manifest are the instructions manuals on how we like Kubernetes to deploy, expose, and run our containerized application. Cool. Manifests are helpful because, why do we think that? So you can also scroll up here if you like to have a quick read, because look at this. Woof. Very, very helpful. 2 paragraphs that should give you a hint on why manifests are very, very helpful. So without manifests, basically Kubernetes wouldn't know how to set up and manage the app. You'd have to manually configure each container every time you deploy, and that's very, very confusing, error-prone, hard to repeat. Okay, manifest is that instruction sheet that Kubernetes can always just whip out of its back pocket and be like, oh, that's how you want to deploy it. Let me do it again. Oh, that's how you want to expose it. Let me do that again for this new container I've created. And know that, these different details like containers to run, how many copies to create, how much memory to allocate, it's a lot of detail that you can provide Kubernetes. So there's a lot of ways you can customize the deployment. Great. So manifests are helpful because it allows Kubernetes to repeat a deployment using the same instructions, e.g. I'll just leave it here for the sake of the characters we have left, but you can think of it as, it repeats the deployment using the same instructions around how many copies we wanted to deploy, what kind of container image we wanted to use, all of that. Done. Wow, very great question from Ranga. In general on DevOps, oof, big question. Which scripting language is mostly preferred or used in industry? It really comes down to your use case here, Ranga. And I would say scripting, you would use, for automation in general, you would use like a lot of Terraform, and you can even use a lot of bash scripts as well. It really depends on your use case here. So I know, very, very generic answer there, but it would be best if you can share like what kind of use cases you want to know more about. Are you trying to create resources here? Are you just trying to run some commands here? I think the popular script language would change depending on what you're trying to do. All right, everyone. So we're just going to create the deployment manifest file now by running this command. Whoa, low battery. Okay, we'll be finished in time. And then once that file is created, you can run the command called nano. Okay, and once you run nano, you'll be able to see that you can actually access the file and even edit the details. So I will replace the ECR image URI, this placeholder over here, with the actual URI of our container image that we're using. Great. So once that image URI is copied, let us paste that in here. Okay, and then save our work by doing Control S, Control X. Done. We've saved the work. And then once that's done, once you've replaced the placeholder for the container image URI with your own container images link or your container images ID, you can now go back to, oh, we need to take a screenshot of it. So we'll do that first. I'm a little sad that you can't actually see more lines. That's okay. We'll just take a screenshot of what we can see. Okay, so like this. And then we'll put that screenshot in here. Great. Well, I would hate to rush the live just because of my computer battery. So let me quickly plug my computer into a power source, everyone. 1 second, guys. This will just be a bit of a setup time. All right, everyone, I'll be back soon. I just need to quickly plug my computer into a power source so that I don't rush the rest of this live. I would hate to rush the explanations. So bear with me, everyone. In the meantime, let me know what you're thinking about this tutorial so far, or add or mention what your favorite food is in the chat, so we can get to know each other a little bit better too. All plugged in, I think. I have power now, which is great. Okay, everyone. It's on my mind that I think I rushed the explanation for this Flask deployment file. So I'm going to go back and actually backtrace a little bit so we can talk about it a little bit more. Apologies for that, everyone. Okay, so I'm going to backtrace to the point where we create the Flask deployment file itself. So a deployment manifest, which is what we've created here, is a file that creates a resource called deployment. when you deploy an app with Kubernetes, Kubernetes' job is to manage, several copies of that app across multiple containers. So when you're deploying an app, Kubernetes' job is just to make sure that every single container that's running your app has the latest version and is running it in the right way. How does Kubernetes actually do that? Well, it has a resource called deployment, which is like a piece of software inside your cluster itself. And that resource handles the actual creating and replacing entire groups of containers to scale your app or to manage some updates. So you can think of the deployment resource as a part of your Kubernetes or your EKS cluster that actually makes that happen. So the deployment manifest that you've created here, flask deployment.yaml, is this file that tells Kubernetes how you want your deployment resource to do those tasks. How many copies of your container or how many copies of your application should it be running? So how should those containers be set up when it creates and shuts down groups of containers? Should it have certain CPU limits? How do you want the network settings to get set up? What is the container image that it should be using? All of the details about the containers themselves. And then once all of that is done, the deployment manifest is how Kubernetes figures out what kind of deployment resource that it will create. So it is a bit of a concept to understand personally, for me as well, because you think about Kubernetes as just this big gigantic tool that magically just manages all of your containers. But the more you understand it, the more you realize that how Kubernetes works is made up of a lot of resources, these separate components of Kubernetes, these separate parts of Kubernetes. And these resources is how Kubernetes has all of these functionalities. Okay, so another way you can think about it is the Kubernetes cluster itself, or the EKS cluster that we've created in the first step. Its functionalities can be broken down into different resources, each playing that specific role and making that Kubernetes magic happen. So in this case, we're creating the actual file for managing what the deployment resource, what that deployment functionality should look like and do. Okay, a bit of a complex concept to grasp, I think, because you start to actually think about Kubernetes not just as one big tool, but as made up of different resources that makes up a lot of its functionalities. But Kubernetes is also much bigger than just the resources itself. So it's a whole web of different concepts all tied together. But the key thing to really understand here is for Kubernetes to deploy an app, you need to figure out what the deployment resource should do and how it should behave. Cool. So with that all set, that's the reason why we had to create this file called flask deployment.yaml, and then even go inside that YAML file to say, oh, this is the image that I want the deployment resource to use when it's creating containers, when it is managing managing updates across all of my containers. Cool. I hope that was all good. And with that done, we'll just exit out of the file again. Okay. And we've put in the screenshot, and we'll just answer that question now. Great. A deployment manifest manages, what does it manage? It manages the creation, setting up of the deployment resource, that's responsible for creating containers, rolling out updates across our EKS cluster. Okay, the container image URL in my deployment manifest tells Kubernetes where my image is. Great. Done. So once that's done, we've exited out of the file. We're back in the terminal now, and we'll just be creating that second manifest file now, and that's called the service manifest. So the service manifest is like the traffic controller to make sure traffic gets to the right place inside your cluster. If you already have your deployment manifest, why does a service manifest exist? So just know that the deployment manifest deploys and manages the app, while the service manifest is about exposing the app to the outside world. So it's a lot more networking related. And both, really, you'll need both to work together to create a fully functional application setup that other users and resources can actually access. Otherwise, if you just use your deployment manifest, chances are it can't be accessed. If you just have the service manifest, you just have some sort of networking setup, but it's not going to actually take your users or traffic into anything that it can use because the application the application hasn't been deployed yet. So I hope that's clear on why we need the service manifest too. And let's create the service manifest file. Okay, we're going to run this code next. Copy it and paste it over here. And this essentially creates the service resource that's taking care of the networking side of things for us for this application. Cool. Just gonna pause a little bit in case we have any questions. All right, and let's answer this right now. A service, actually not a service manifest, apologies everyone. A service exposes a deployed application to users or to traffic. My service manifest, what does it do? Sets up, so we can actually revisit the code here to understand what we've done. Cool. So as you can see here, you have your service manifest. There's an API version. The kind says we're trying to create a service resource. Great. And the metadata says the name of the service resource should be Network Flask Backend. And what else is here? We say that we want to use node port to expose the application at port 8080 of the cluster. Okay, very good. So the concept of node port is honestly quite complex. It's a bit more advanced, and we won't be covering it in this project, but potentially in future extensions of this Kubernetes service. But just know that this Flask service YAML, this Flask deployment, is all about exposing your application at port 8080 within the cluster. Okay, great stuff. We're just going to answer this together. Our service manifest sets up a service resource that exposes our backend application at port 8080 within the EKS cluster. Okay, so what that means is internal traffic that hits port 8080 of the service resource will route that traffic to the backend application. All right, all done. So congratulations, you've created your manifest files, which are the final missing pieces for your Kubernetes deployment. So let's head on into deploying the backend application now. Woo! Congratulations, we're now here at deploying the application in one simple step. I know, we've done all the hard yards of setting things up, and now we get to just deploy it with two things that we need to do. Install a tool called kubectl, which is a command line tool for using Kubernetes, and then deploy the app with Kubernetes. And of course, we'll be using kubectl, the tool we install, to run the command for doing that. So I'll let you have a look at this. Oh, I just realized the image should be showing this instead for you are here. So we'll actually be highlighting this part instead of this manifest files part. I'll be updating this right after this demo for sure. Thank you so much for your patience, everyone. Yeah, and Bamisha in the chat says this project is quite extensive. Yeah, pro projects are quite extensive, aren't they? It truly gives you that an experience of going from doing something from scratch all the way to deploying that application using a pretty in-demand complex tool. And also, if this is the very first Kubernetes project you're seeing, just know that this project is split up into 4 different parts, and you are seeing the last part right now, which brings together everything you've done in the first 3 parts too. Okay, so in this step, we will deploy our application using kubectl because it's the command line tool for creating and managing Kubernetes resources. Great. Okay, so how are we going to do this? How are we going to deploy the application using Kubernetes? To do this, we'll be using commands that apply the manifest files. So let us copy the code here and let us run it in the terminal. Aha! So these commands are here to actually say, I've created these manifest files. I want you to apply that in my EKS cluster. But as you can see, we actually ran into some errors. We ran into some errors here that says the kubectl command is not found. So what's happening here is we haven't installed kubectl. This tool does not exist in our EC2 instance yet, so we need to install it first. Okay, so we're gonna run the command to install it, which is right here, and let us answer the question around what is kubectl as well. Okay, so what we are installing over here is the command line tool for interacting with Kubernetes resources like pods, deployments, services, and what we need to know here is that kubectl is not about creating the EKS cluster. We already had another tool called EKSCTL at the start of this project for it. Kubectl is about, once you've created your cluster, how do we create the resources inside? So that's the differentiation between kubectl and EKSCTL. Cool. So what is the thing that we've just installed? Kubectl is the command line tool for managing resources inside the cluster. I need this tool to deploy, we need this tool to deploy the application by creating the deployment and the service resources. We can't use EKSCTL for the job because that tool is for creating the cluster. Okay? It's for creating and managing an EKS cluster, whereas kubectl is more about creating and managing resources inside your cluster. And as you can notice, kubectl doesn't mention EKS in it because you can use it for more than just Amazon EKS. You can also use it for other Kubernetes management or orchestration platforms. Great. So once we've installed it, let us run the command for giving us the permission to use kubectl. And we'll run this command to check the version, which tells us that we have successfully installed kubectl because there are 2 version numbers that pop up for us, which is great. When that's done, we'll just take a screenshot and go through with applying it. But I do see that Ranga has some questions in the chat here around scripting languages like Python and YAML. It is quite an experience, like learning how to use YAML, but there's so much documentation around that, Ranga, that you don't have to think about writing scripts as starting with a blank page and writing every single line from scratch yourself. Think about writing scripts to start with as using templates from documentation that's already out there. There's documentation around how you can write manifest files. There's documentation around how you can use Terraform. There's documentation around using all different kinds of scripting languages out there. So use the templates that's already out there. And I personally would recommend that if you have some worries about scripting and DevOps and some questions around it, I would recommend actually asking these questions in the Nextcode community, because that's where the entire community can talk about it asynchronously as well. This project is about Kubernetes and kubectl, so we'll stay focused on what we're here to do in this project today, but that doesn't mean you can't ask these questions at all. I think we'll be able to share a much more thoughtful response if it's in the community, actually. So I'm not sure if anyone in the chat is able to do it, but if someone in the chat can share that link into the Nextcode community in the chat, that would be much appreciated as well. So Ranga knows where to go to ask these questions as well. Cool. Run the commands to apply your YAML files. So these are the manifest files that we've created. And you should know what these commands are. Do you know why? Because we have actually gone through those commands earlier. Okay, so earlier we have these commands over here. So don't forget, these are the commands for applying your manifest files, and we'll run that here. All done. So everything is created now. And Ranga, sending lots of love to you. No need to apologize for the diversions at all. I really appreciate your curious mindset as well. So thank you very much. Thank you very much for being here too. And once we have run the commands for applying the manifest files, what's going to happen is we'll just take a screenshot of the terminal, showing that we've applied it. Boom. There we go. And then respond to this question about what we actually did to the backend application. To deploy our backend application, we applied the manifest files that we created. Applying a manifest file means giving Kubernetes the instructions that we've written inside Flask deployment and actually giving Kubernetes the templates that we've written, giving Kubernetes the templates for creating the deployment and services resources to deploy plus expose our application. Great. Nice work. So with that command done, we've actually just used kubectl to apply the manifest files. It simply deploys your app across the cluster. All right, so if you're wondering, oh my gosh, is that it? That was the finale of this whole project about deploying a Kubernetes cluster? Well, look no further than today's secret mission, which is going to get you to verify what you've deployed today. And it's awesome, this step. I really, truly love it. Beautiful Tay. Wow, what a name. asks about another project series that we're doing with CI/CD. So that project you will get to see an update for maybe next year once we've built out our pro project collection. If you'd like to know more, please check out the Nixer community as well to ask that question there and to see all the updates. Thank you, beautiful Tay, for being here. Okay, so in the secret mission, we're going to be doing some fun stuff about verifying the EKS deployment. We're going to view the EKS cluster in the console, and then we're going to use that console to look for updates that shows us that we have actually deployed the application backend. And then, of course, we're going to add all of that juicy work into our project's documentation. All right, Boris also has a great command in that you've chucked into the chat there, Boris. kubectl get pods is a great command you can use to check what you've created. I mean, in fact, let's just run it here. Thank you, Boris. All right, and you can see that there are some results showing that kind of shows you Nexthook Flask backend, your backend application, and all of the deployment and the resource, the service resources that you've created. Like things are running here, all right? But looking at kubectl get pods is a little bit, I would say, advanced if you're new to the concept of pods, if you're new to looking at things in the terminal. So we'll be actually using a more visual way to look at all of these updates using the console. So let's jump into today's secret mission and see it, okay? Phew. Let's jump in. That was beautiful. Okay, so in this secret mission, we will use Amazon EKS to view our cluster because we can check for updates, events related to our deployment in the EKS console. Great. Okay, so to get to the EKS console, we'll just need to open up EKS in a new tab. So let's fire up EKS like this. Whew. And in that new tab, I clearly need to zoom out so we can all see this, but not too out. Otherwise, it's a bit too small on the screen. And once we have access to the EKS console, let's click into the cluster that we've created. And you can see, you can scroll down, and you can see some different resources related to your EKS cluster. You can go into compute, for example, and you can see a node group. Okay, and a node group is something that you've created all the way back in step 1 when you ran that create cluster command. Okay, so this node group has been created. It contains 3 nodes, and each of those nodes, each node is a group of containers that's running whatever container you're asking it to run, or containers that are running like the application or the deployment resource or service resource, all that stuff. Oh, actually, sorry, let me clarify that right now. The node group isn't exactly the place where all of your resources live. Sorry, I should have mentioned that. The node group is where you have your containers that's running the application and just running anything else that you've asked it to run. The resources, which are kind of like the deployment, the service, they live somewhere else called the control panel, and that is separate. You can think of the control panel, which is like the brains of your cluster, to live somewhere that's separate to the node groups and the nodes, which are kind of like the muscles of your cluster that's actually running the application. Sorry about that confusion, everyone. But let's clear it up by just exploring this EKS cluster together. So if you scroll back up, you can see that there are 2 banners in blue. Can you see those 2? Okay, these 2 banners are actually telling you that you have access to your EKS console. You're looking at it right now, but you actually can't see the nodes. You can't see the actual groups of containers that are running inside your cluster, it says no nodes here. The reason for that is because you actually don't have the permission to see those nodes, and that's why they're hidden from you. Even if you're an IAM admin user in your AWS account, you can't see those nodes because Kubernetes has its own way of managing access within a cluster, and inside Kubernetes system, you don't have access. So in order to gain access, you can either click on that Create Access Entry button over here, which takes you straight to the page for giving yourself permission, or you can also go into Access here, this tab, and create access entry from here. Both get you to the same page. And a big shout out to Viresh for saying hi from India. Hello, Viresh. Good to see you here. All right. So this is one way that you can create access or give yourself access from the console. But since we've been doing so many things from within the terminal, I think our challenge for today for the secret mission is also to just try create the permission settings within the terminal as well using commands. It's pretty fun. Okay, all we have to do is head back to the terminal. And how can we go from here, the terminal, to creating access permissions for us to view the resources in our cluster? It's pretty cool. To do that, we actually have a fabulous EKS command that we can use called create IAM identity mapping. So let us copy that, and we'll just paste that in the box over here because there's something in the middle that we need to replace, and that's the user ARN. This command is going to give us the access to our EKS, Nextware EKS cluster over here. But in order for this command to work, it needs to figure out who is the IAM admin user that I need to give EKS cluster permission to, EKS cluster access permissions to. Oh, that was such a mouthful. So we need to give it the ID of our own IAM admin user so that we can make that very, very clear. Let's find the user ARN. It's quite close to where we created the role just now in step 1. Where you can find your user is by visiting the IAM console, heading to users, and then clicking on your user's name. When you have your user's name, you clicked into it, you can copy the ARN right over here, and then you can put that into the command that you're using. Okay, so we have all the ingredients we need to just now run this command that gives our own IAM admin user the permission to see, our cluster's nodes. Now, I just realized that there's something missing from this template, this template command. I'm getting exposed live, everyone. As you can see from this error message here, there's something missing. Can you tell what's missing? Actually, I'm not going to say it right away. Let's see if we can tell what's missing from the command I ran using the error message. All right, so what's missing in our command here is the region. Oh my goodness. I totally forgot to add in that we actually also need to tell EKSCTL the region of the cluster that we want to edit permissions for. So let's add that. Let me paste that command one more time. Okay, and this time we're gonna add region information in here. Oh my goodness. Let us add that in here. Region. That looks a little funky, doesn't it? Region, like this. And let us put in the code for our region. So I know mine is US East 1. Which code are you using? Oh, just realized there was I accidentally just typed a little shortcut that I wasn't supposed to use. So let me just do that one more time. Oh, okay. we can run that now. So as you can notice, sometimes that the terminal looks a little funky over there, but that is just like some classic formatting that happens inside the terminal. Just keep typing the command if you see that some of the text just goes a little like awry over there, but it's okay. I've just kept on going. I've typed in the region code, and once I run it, you can see that it's successfully running the command now. Okay? So let us head back to our EKS cluster and see that we've created the access entry. So we can go into our access entry, and then we can refresh. Okay, do you see how that blue banner at the top that was warning us about our permissions, that's gone now? And you can even see, oh, can we see it? Is it here yet? Oh, it's not here yet, but let's see if we can actually just see the nodes. Ah, we can. Very good. So we have the permission to actually see the nodes inside the cluster now, which is great. And let us write this quick reflection about what we've just done. Vresh in the chat says you've only covered Kubernetes in the DevOps syllabus. We've also covered the CI/CD pipeline, actually, Vresh. You can check that out in nextweek.org. Awesome, thanks for the question. Our extension for this project is to use the EKS console to verify our deployment. We had to set up IAM access policies because, why is that? Because we don't have access to see our cluster's nodes by default. We set up access by running a create IAM identity mapping command. By running create identity mapping, okay, in the terminal. Cool. So we're going to click into any of these nodes now to see what's inside. So we know that a node is actually a group of containers that's running your application or that's running different things inside. So let us click into the node to see what it looks like. Okay, so scroll. And here we are. We have actually something called pods here. Do you see how there's nothing that says containers or like the number of containers that's inside this group? Instead, it's actually the pods and the number of pods. Why is that? So the reason for this is because while we've been thinking about Kubernetes clusters as bunches of nodes running your containerized application, there's actually another thing that you can see by zooming into each node. Each node is made up of pods, and each pod is a bundle of containers that work together in a unit. Pods are the smallest thing that you can deploy, so you can't deploy containers on their own with Kubernetes. You actually need to make sure that these containers are inside a pod. So that's kind of like the structure of Kubernetes. So you have a cluster. The cluster is made up of the control panel and also your node group. Zoom into the node group, or really just zoom into the worker. I think it's called the worker plane. There's a control plane and there's also a worker plane in a cluster. And then you zoom into the worker plane, there's node groups, and then you zoom into the node group, there are nodes. And then you zoom into a node and there are pods. Zoom into a pod, and what's there? Bundles of containers. So you can think about this huge architecture just getting broken down like layers of an onion. And pods are actually the smallest deployable units in Kubernetes. We manage and deploy pods. We don't actually manage and deploy like single containers. Okay, so the smallest deployable unit, the smallest thing we can even deploy, is still a grouping of containers that's called pods. Now, why do we use pods? It's because pods makes it very, very efficient to run multiple containers. Once you bundle containers into a pod together, they actually share the same network space and storage space, so that these containers can communicate, they can share data, they can run a lot more efficiently. So your application is even more efficient too. Great. Thank you so much, Viresh, for adding timestamps in the description. We're actually starting to do that for every single Project Live demo now. So check out all of the Project Live demos in this channel. You should see that they have timestamps. Yeah, something that we're very proud of that we started to finally do just in the last 2 weeks. So thank you very much. We'll make sure to do that for this one too. Okay, so once we gain access into our cluster's nodes, one second, I just noticed one thing that I will be editing right after this. It's just a little typo. It should be gaining access into our cluster's nodes. Once we gain access into our cluster's nodes, we discovered pods running inside each node. Pods are the smallest deployable unit and represent bundles of containers. Containers in a pod share networking and storage resources. I would say making the app efficient. Once we accessed our cluster's nodes, we discovered pods running inside each node. Pods are the smallest deployable unit and represent bundles of containers. Containers in a pod share networking and storage resources, making the app run efficiently. Nailed it. Done. We're at the last stretch of the secret mission now. One more thing to see. As you can see that there are some pods that says backend in them. We're going to select that. And then we're going to scroll down and see that there are events in this pod. So what does an event mean? What does an event mean? So events are basically things that have happened when Kubernetes was creating this pod, or anything that relates to what this pod is doing, setting up, will be logged as an event. And here's what each event means. Okay, so you can see that there are how many? There are 5. And the first one is about successfully assigning something, okay? Which means that your pod has been given this internal IP address in the cluster. It gives it an address so traffic can be taken to the pod. And then you pull the image. Which image is it? This might look a little familiar. It's the URI of the image in your container registry. It's this thing that you copied, okay, in your ECR repository. And then it says that it successfully pulled the image. So the image is successfully getting used and downloaded into the cluster here, into the pod here. Then we created the container using that image. And now the container is successfully started and is now running inside your pod. Look at that. So long story short, your backend has definitely deployed somewhere. The entire flow, your container image, it's finally been taken. It's been used to create an awesome container, okay, to run the backend. And we simply haven't visited the location of that backend yet, but it is somewhere. You can challenge yourself as an extension for this project to visit that location, or you can wait for the continuation of this Kubernetes series that's going to come to you in the future. And in that continuation, you'll get to see the backend. You'll get to deploy the full application, which is what Viresh in the chat is also asking about, Viresh. So you can host the whole app and the extension of this project coming to you in the future. And then you can also use load balancing to manage the traffic across the entire cluster. It's an awesome extension once you've set up your foundations with this project too. All right, so let's take a screenshot of the events panel. And let's drop that into our into our screenshot area, screenshot task, and we'll just answer this last question about our secret mission. The EKS shows you the events for each pod where we could see the container image getting pulled and used to create a new container running the backend application. This validated that the deployment was successful. The backend is running. Great. Or really, you can say that the backend is deployed. Well, you can say that the backend is running as well. Done. Okay, so once we've made it to the end, you can now actually delete everything. You can absolutely challenge yourself to try deleting everything on your own first. But just know, even after you've done it yourself, make sure to double check the steps in here so you can make sure you've deleted everything. We just want to make sure AWS doesn't charge you at all, especially the EKS cluster, which again costs 10 cents per hour. So let us run this command in the terminal to delete our EKS cluster. Great. Oh, and again, we need to provide the region. My bad. Let us provide the region of our cluster in this delete step. Oh my goodness. Something funky is happening with my terminal. So let me just write out the entire command here. So EKSCTL, delete cluster, name is nextwork. I see, that's why. That's why it's going a bit bonkers. It'll look like we're writing over what we've written, but it'll just be one consistent line. Nextwork EKS cluster. And then we'll need to add the region, which for us is US East 1 for this project. Okay, so it's deleting now. And you can see sometimes that there are some error messages for the deletion. Don't panic, don't stress. If there's anything that doesn't work, you can always check what's happened in CloudFormation. And this honestly has happened most of the times that I've deleted something, but the rest of the cluster, the node group would just deploy fine anyway. So don't stress. Now we're starting to delete the cluster now, and let us delete the EC2 instance, so this instance itself. So to delete the instance, all we'll have to do is visit our instances tab, or you can visit instances just by typing it in the search bar. And select that to visit the page straight away, which is this page. And once you select your Nextwork EKS instance, I'm sure you know what to do. Select the instance state and just terminate it like this. Done, okay? And once you have started to terminate that, I think the other thing to terminate here is your ECR repository. So this is the container registry that is storing the container image that you've built today. We don't need it anymore, so we'll just delete that now as well. And just like that, you've deleted the resources for this project. Thank goodness for documentation and that we've taken screenshots and answered questions along the way so that we always have a copy of our work, even if all the resources have been deleted now. Okay, so let us just write a few last words about our project today. I used Kubernetes, ECR, kubectl. Yeah, what were all the tools that we used? We used Kubernetes, ECR, kubectl, Docker. Any other tools? kubectl, and there was definitely EKSCTL. Oh, and there was Git as well, GitHub. to deploy the backend of an application. Key concepts include using manifest files, maybe applying manifest files, building container images. What else did we do? And pushing them to a container registry. Great. So how long did it take you to complete this project today? Well, this project took us approximately 2 hours, including demo time. The most challenging part was there a part you found challenging? Well, I would say the most challenging part was, if I was being cheeky, I'd say running terminal commands and then seeing the formatting look a bit funky. But I guess in this step, we can talk about the most challenging part was creating the manifest files. And what's our favorite part today? I'm sure you might have one too, so you can add it to the chat. For myself, the favorite part was verifying the deployment in the EKS console. I quite like that because you get to really visually see everything about your cluster inside Amazon EKS. That was quite fun, and to actually see the events of your container image getting pulled, a container successfully getting created. Oh, so satisfying. Really, it almost like sees your work just come into fruition. You know, all of the setup that you've done. Like, it was all worth it. So that would be my response. And why do we do today's project? We did today's project, write down your own reason. We did today's project to learn about Kubernetes and how to deploy an app with Kubernetes. This project gave us the end-to-end experience deploying backend. Next up, surely we'll learn to deploy the rest of the app and load balance as well. Great. So with that done, that is a wrap. Oh my gosh, we made it to the end. That was a wrap. You just deployed the backend of an app with Kubernetes. Wow. Guys, that's huge. Give yourself a pat on the back right now. Add it to the chat, celebrate in the chat. It's a huge thing to celebrate. And it's cool to recap and see what we've learned today. We've learned how to build and push a container image. We've wrote the manifest files. We've even deployed it with Kubernetes using kubectl. We've even viewed and verified our deployment using the EKS console. So when you're ready to learn everything about Kubernetes, we can talk about this more in the second Kubernetes series that will definitely come out in the future. But in the meantime, we'll be keeping busy with some other new pro topics to explore. This is cool. I see Viresh in the chat asking, if I want to learn full AWS security, what are all the topics I want to learn? Give me exact roadmap. You can talk about that in the Nextweek community, Viresh, so that we can keep on going with this project today. The community, the Nextweek community should be in the link in the description, actually. But if you can't access it, I'll share with you the link right away. The link to that should be right here. One second, everyone. I'll just share with you the link to the community, Viresh, so you can ask about the questions about AWS security. Thank you. So with that all done, we've accomplished today's mission. Poof. And that is a wrap for today's project. Well, you can definitely check out your documentation. You can also share your work on LinkedIn. You know, if you just click on that share on LinkedIn button, look at what you get to see. Awesome stuff. You get to automatically get a pre-filled LinkedIn post that tells the world about what you've done in today's project. And then you can even add a document to add the documentation that you've created as well. So perfect timing. I can download my documentation now, and we can open that over here. Oh, it's still downloading, it seems. That's cool. I can see that it's downloaded here now. Great. Let us open and see it here. Wow, look at that. So all of the work that we've created in today's project shared in a very, very clean documentation that goes through all the way from the setup, like creating the cluster, the backend code, our container image, the manifest files we've created, and then even the deployment and the secret mission too. So that looks super satisfying. And it's a great summary of all the steps that we've done today. So you can definitely share that on LinkedIn, add it to your portfolio. Great. So if you'd like to add this to your post, you can just add the document and then attach your document in there. So you can add your name. So you can say next work, and then the name of today's project, which is deploy backend with Kubernetes. All right, so that's a wrap for today's project, and I can't wait to see how everyone goes with today's project. Share the love, add a comment about how you found it, and we'll see you in the community. All right, so if you have any questions as well, by the way, the community is here to help each other out. The link is in the chat, it's in the description, and yeah, hope to see you there. Yeah, it's been a great journey with this Kubernetes series. If you are wanting to see any other big topics for your next pro project, again, I would love to hear about them, so you can add them to the comments or in the community too. All right, see you everyone. Thanks for today's project, and a big shout out to everyone in the chat for all of the love. Bye.